In this video, we'll discuss piecewise defined functions. Now, a piecewise defined function is a function that's constructed from multiple functions over different intervals. So you might ask, well, what does that look like? The most common format is that you'll see something like f of x or y or g of x or some function is equal, and then you're going to have one set of brackets, and then you're going to have all the functions listed, and then to the right of each function is an interval for which that function exists. Now, if we need to evaluate a given value within that function, the first thing we do is figure out where the value exists, so in which one of these intervals, and then we substitute the value in and evaluate the function on that given interval. Now, it's easier to see an example of this. So one of the most common examples in the real world is the tax system that exists in the United States. So these are the tax brackets in 2021 in our progressive income tax system. Progressive income tax means that as you make more money, you progressively pay a higher interest on a chunk of that money. So here are the 7 tax brackets that currently exist, and these are where those brackets break down for each of those different ways. So if I look at a single person, I want to know what would they pay if they made $92,000 in income. So the first thing I want to do is look at my how my intervals are set up and find where would 92,000 be located, and it would be right here. So that means that I'm going to take my 92,000, substitute in for x, and then solve that equation. So the tax value at 92,000, so I substitute in 92,000, I simplify my parentheses, I multiply, and then I add my two values, which means that at $92,000, the person would pay $16,101 in taxes. Now, I'm going to say this because this is important to understand in context of this problem. They did not pay 24% on all of their taxes. They paid about 17.5%. Again, that's the progressive tax. They paid 10% on a little bit, 12% on a little bit, 22% on a little bit, and 24% on a little bit. So it breaks it up, and they only paid that 24% on a very small portion. All right, so let's look at another example. What if they made $55,000? So if they made $55,000, we'd be looking at the 22% tax bracket because it falls between 40 and 86,000. So I substitute in 55,000. I simplify my parentheses. I multiply, and then I add my values. And you see here, I put 50 versus just 0.5 because we're dealing with money, and that's 50 cents. So the taxes then would be $7,848.50. So in this case, if we actually look at the overall percent then, they only paid about 14.3% of their income in taxes, not the full 22%. That's how the progressive tax system works because it is a piecewise defined function. Now, what if we need to graph a piecewise defined function? If we're doing it by hand, the first thing I do is graph that function completely, just do it very lightly, and I use key information about that function. For example, if I have a linear function, I would use the slope and the y-intercept to graph it across the entire graph for which I have. Then I would go back and erase the portions of the function that fall outside of a given interval. So if it ended at, say, x equals 1, then I would erase everything after that. Now, it is important, though, that sometimes when you graph these different functions, they're not going to meet at a given coordinate. When that happens, you need to put an open and closed point at the different locations to represent where's the function defined and where is it undefined at that given point. Now, if you use Desmos, you can actually enter each function on its own separate line, and then you put the interval for which that function exists in brackets. For example, if I had y equals x plus 4, I would then put the interval inside the brackets where a would be a number. This could be just less than or equal to. X is less than or equal to some other number. So let's look at 2 examples about how this could work. So first one, here we have a piecewise function. We've got x plus 1 when x is less than -1. Y equals 2 when between -1 and less than 5. And then it's 2x minus 8 when x is greater than or equal to 5. So everything beyond that point. So let's take it one function at a time. First thing I would do, I would graph each function. So I'm going to start with y equals x plus 1. So I know that gives me a slope of 1 and a y-intercept at 1, and this would be if I had the entire graph. The next one says y equals 2. That is a horizontal line at the value of y equaling 2. The last one, 2x minus 8. That tells me that I have a y-intercept at negative 8 and that I'm rising and running, doing my slope, at a positive 2. So now I go through, and at this point I'd want to go within my intervals. So the x plus 1, my line here, ends when I get to negative 1. So I would need to erase everything all the way back to negative 1. Then for 2, it goes from negative 1 to 5. Now I'm going to put a solid dot at negative 1 because it's equal to, and a hollow dot at 5 because it's less than, so that it only exists between 1 and 5. Now I'm saying that the last function goes for everything greater than or equal to 5. So now I can put a solid dot at 5, and then I erase everything before that. So here you can see one place the two lines intersect, another place they don't, so I have to define where that point exists at that given location. So the hollow dot means it's undefined, and the solid dot or solid point tells us it is defined there. Now let's look at one more example. Say we have x squared, x plus 1, and 8 minus x squared. Now this one has very specific definitions of where it is defined. So we have negative 3 is less than or equal to x is less than or equal to 0. 0 is less than x is less than or equal to 2. Then 2 is less than x is less than or equal to 4. So it actually goes only from negative 3 to 4. That's the domain of this piecewise function, which can happen in real-world situations. So if I'm going to use Desmos, so I'm going to go to Desmos, and I'm going to do one line at a time. So I have y equals x squared, and then I need to push to the right so I get off of the exponent. So that's if I have the entire thing, but I have to do my intervals. So I'm going to use a bracket, and I'm going to say negative 3. And if I do the less than symbol and then the equals to, it'll put the equals under it. X less than equals 0, and I close my bracket. Then I hit enter. Now, say I want to make it so that that line is easier to see or whatnot. If I click and hold over, I can change the line width. Say I want to make it, say, like 5. Makes it a little bit bolder. I can change the color. I can change whether it's dotted. So I can change some features to make it a little bit easier to see if I want to. So let's go to the next one. Y equals x plus 1. Now we can see it goes through here, but we only want it restricted. We go from 0 less than x less than equal to 2. And then I close my parentheses. And you can see how much shorter that little piece becomes. And I'll keep it this color, but let's change it so it's a little bit easier to see. We'll change that width to 6. A little bit easier there. And then let's go to the last one here. Y equals 8 plus x minus x squared. And this is, I need to push to the right. I do my bracket. This goes from 2 is less than x, less than or equal to 4. And you notice that every time it gets to that point where it's one or the other, one has to be equals to and one has to be less than or greater than, because you can't have the same value work on two different functions. It doesn't work that way. It has to be one or the other. And here I can see then, I'm going to change this color because it looks too close to the first one for me, and I'm going to go in and make it a larger value. And if I expand this, I can see it goes from negative 3, 9, comes down to 0, 0, jumps up to 0, 1, goes to 2, 3, and then goes from 2, 6, all the way to 4, negative 4. Now, sometimes it's hard to tell, like if I want to evaluate it, I can always come back and put points in myself. So I could put in negative 3, 9, and if I want to change it, that's a solid dot, a solid point. But I could make it larger if I wanted to, and I could even change its color if I wanted to like verify that. And then here at 0, again, I could always do 0, 0, 0. And that's also a solid point. And I could go through and just keep putting in the points. So this one would be 0, 1. Now here at 0, 1, that's the second equation. It's less than. So I would just want to make sure that anytime that happens, I use the open circle to represent that point. And I could go through and do the other three the exact same way and have all those points listed on my graph. And that will help me as I try to go and evaluate at a certain point within this piecewise function.